Hi, Dan from Cloudsmith here. If you're building and delivering software, you're already creating and using software artifacts. Packages, libraries, containers, binaries, and configuration files. These are the building blocks of modern applications, moving through your pipelines and into production to power your business. Cloudsmith is a cloud-native platform for managing software artifacts. It lets you control, secure, and distribute your artifacts as part of the modern software supply chain. I'm going to demonstrate how Cloudsmith works. You'll see how to manage your organization and teams, set up repositories, configure access and governance, and add or track packages, including those from third-party sources such as open source software. We'll also cover how to enforce compliance, scan for vulnerabilities, define and automate policies, sign artifacts, distribute packages, and work with the API. This is a quick, practical overview to help you understand how Cloudsmith supports real development work, from securing builds to distributing software globally. Now let's get started with the demo. So I've logged into Cloudsmith and into my DMK Software Solutions workspace. A workspace on Cloudsmith is similar to an organization on GitHub. That's the top-level entity where you create and manage package repositories, where you manage your users and teams, and where you can configure things like policies. What you see on the screen here is essentially the overview page for my workspace. And that's where I can see at a glance things like the number of quarantine packages, the number of vulnerabilities that our security scanning has detected, and even usage data, like the total number of packages and how much artifact data I'm storing at Cloudsmith. But of course, the core of any artifact management platform are package repositories. And you can see a list of the repositories in my workspace here. If we look at one of these repositories, you'll see that Cloudsmith repositories are actually fully multi-format, which means I don't need to create a separate repository or registry for all of the package formats that I wish to use. We also have integrated Upstreams support, so I can, with a single click, add a connection to an upstream where I want to fetch open source packages from. I don't need a virtual repository type of construct or anything like that. I can have local and remote packages together in one repository in Cloudsmith. We also have policies. Policies in Cloudsmith allow you to leverage package metadata like security scan results or license scan results, or in fact, any metadata that we have about a package. Policies in Cloudsmith are written in Rego. The policy engine is based on Open Policy Agent. So it's a really powerful way to implement some controls over package usage and consumption. And finally, we have some organization settings, things like authentication for SAML single sign-on and OpenID Connect for creating secure connections to third-party tools and services. Now that was a very quick overview of Cloudsmith, but on this page, you'll find lots of other videos where Ciara and I take a much deeper dive into individual features and functionality. And really, we want to explore how Cloudsmith can help you secure your software supply chain. So let's start by taking a look at some of the things you'll want to configure in your workspace for your organization. So we'll start off with some organization settings. So you can see here where I've configured my workspace name and my contact email address. This is also where you can configure authentication. Cloudsmith does support authenticating with username and password, but typically most enterprises will set up SAML single sign-on, and Cloudsmith supports all of the popular identity providers for SAML. We also support synchronizing groups from your identity provider with teams in Cloudsmith. And that gives you a really nice way to automate the membership of teams. So you don't have to manually add or remove users from teams. We support SCIM, the system for cross-domain identity management, for provisioning and deprovisioning user accounts automatically. That's really important for compliance. You need to be able to demonstrate that when you offboard a user from Cloudsmith, their account is automatically removed. And finally, we also support OpenID Connect. I really like OpenID Connect. It gives you a really nice, seamless and secure way for third-party tools and services to authenticate to Cloudsmith. I'll revisit OpenID Connect in a bit more detail later on. So at a workspace level, your users who log in can be granted one of 4 roles. Those roles are owner, manager, member, and collaborator. Now, these are workspace level roles. They don't automatically grant any privileges on package repositories. Access to package repositories must be explicitly granted or inherited from a team membership. These organizational roles or workspace roles, they really control what a user can do at a workspace level. So things like managing teams, managing policies, and changing workspace settings. Cloudsmith also supports service accounts. And you can see here, I have service accounts for things like GitHub Actions, for my Terraform provider, for infrastructure as code and provisioning resources on Cloudsmith with Terraform, and for some other CI tools that I use. Service accounts are just like user accounts, except they're not tied to a human being. They're primarily used for third-party services and tools to authenticate to Cloudsmith. And used in conjunction with OpenID Connect means that you don't need to store these service account API keys in your third-party tools and services. You can group your users into teams, and that's really good because it allows you to grant repository access to a team rather than to specific users. And when you combine that with SAML Group Sync for teams, where you've automated the membership of teams, then it really gives you total automation and control over repository access. Some other things that you can set at an organizational level or a workspace level are policies. Now, we'll take a much deeper dive into policies later. But policies essentially allow you to control the flow into and through your package repositories of artifacts in a very fine-grained way. You can leverage data from Cloudsmith security scans, from our license scans. You can leverage any package metadata at all in package policies. But that really does warrant a much more involved discussion. So those are essentially the core components of a Cloudsmith workspace. So we covered how you're going to set up authentication for your users. Things like SAML, things like SCIM and OpenID Connect. We covered how you're going to group those users into teams and use those teams to provide access to repositories. And we talked a little bit about how you can implement policies at a workspace level to control package use itself, and the flow of packages into and through your repositories. At this point, you have a workspace, you have invited some users, you have some teams, you're now ready to look at the core of an artifact management platform, which is package repositories. Package repositories are arguably the most important part of artifact management. So let's now take a look at how we would create, manage, and use package repositories. So let's talk about package repositories. As I mentioned, repositories are the core of an artifact management platform. But it's actually really, really simple to create a repository on Cloudsmith. Now, I'll do everything here in the user interface, but of course, you can manage Cloudsmith using our REST API or the Cloudsmith Terraform provider. And we'll have a deeper dive into that in a later video. But if I wanted to create a repository, it's as simple as giving the repository a name. I'll just call this demo repository. And I can choose a storage region for my repository. The storage region isn't really related to performance. Cloudsmith has a package delivery network that is global with 600 points of presence. And typically people choose repository storage regions for regulatory or compliance purposes. I'll put this in Dublin, Ireland, close to me, and I'll create the repository. We now have an empty package repository. Now, one of the things that you may have noticed when I created this repository is that I didn't need to specify a package format for the packages in this repository. That's really important, and that's because Cloudsmith supports multi-format repositories, which means I can push and pull any of these 30 package formats that Cloudsmith supports to and from my Cloudsmith repositories. That gives me an awful lot of flexibility. I don't need to structure my repositories by ecosystem or by language. I can structure my repositories by things like environments. So production, staging, development repositories, or by products, or by teams, or even any other structure that you want. So it really is a fundamentally more flexible way of laying out repositories within my workspace. But looking at our demo repository, so it's empty at the moment. We'll push some packages to it shortly. But what kind of things do we want to configure or set up at a repository level? So the very first thing is probably access controls. So who or what is able to access this repository, and what are they able to do? So because I created this repository, I'm the administrator in the repository. I can also add a service account to this repository. So I'll add my GitHub Actions service account, and I'll give that service account write privileges to the repository. And I can even add teams. So I'll maybe add a dev team, and I'll give that dev team read permissions. So with a simple configuration like this, my developers can pull packages from this repository. My third-party services and CI pipelines can publish packages to this repository, and I am the administrator of this repository. I could, for example, add an ops team as well and make that team the administrators of the repository as well. And I could add other services if I needed to. That's the repository configured for read and write access. Well, what other kind of things do we want to configure at a repository level? Or what other options do we have for repositories? Well, Cloudsmith repositories support automated lifecycle or retention rules. So I can enable these, and I can say, let's keep 100 versions of every package type and format that I've got, every name and format that I've got. So this is a really great way of controlling not just how large your repositories get, how much artifact data they contain, but also what they contain. So I can limit by days. I can keep a maximum number of days, or a maximum count, name and version, or a maximum size. So I think it's really important to exercise some control over repository size and scale, essentially. Now, not taking these settings in order, but in the way that they make the most sense, we also have GeoIP rules, and I can enable these for the repository. I can say, I only want to allow access to this repository from the United States, for example, and the United Kingdom. This allows me to control not only who can access this repository with valid credentials, but from where in the world they're accessing the repository from. So there's a deny list that I've created for the United Kingdom and the United States. I'm going to delete those so they don't break my demo flow. But this is additional security controls above and beyond just configuring read, write, or admin access for a repository. We also support repository webhooks. Webhooks are a great way to get notifications about package events within a repository. So this has events like packages being quarantined, or the tags updating on a package, or even just a package being created, a package arriving from a CI build. Webhooks are a brilliant way to trigger additional tools and services to do things in response to events within Cloudsmith. Finally, and I think probably most importantly, Cloudsmith repositories support upstream sources. In some other artifact management solutions, you may see different repository types like local repositories and remote repositories. Cloudsmith just has Cloudsmith repositories, and they can have upstream sources. So upstreams are additional package sources that you want to integrate with your Cloudsmith repository. You can see on screen, we have simple one-click configuration for most of the canonical upstreams, things like Maven Central, PyPy for Python packages, or NuGet.org for NuGet packages. I've just configured 3 upstreams on this repository. So I am now ready to request packages from my Cloudsmith repository. And if they exist on upstream sources, they'll be served through Cloudsmith. In addition, packages from these upstream sources are cached within Cloudsmith. So Cloudsmith retains a local copy of any packages that are fetched from an upstream source. That's really important. That does provide an isolation layer between you and the public upstreams. So in the case of, say, some availability issues with a public upstream, you have your own local copy of those packages, and they live right beside packages that you can publish to the Cloudsmith repository as well. So in many ways, this demo repository is already a combination of packages that I may publish, like a Maven package, and packages that I can fetch in from public sources. So I get the best of both worlds in one place here. So that essentially covers creating a repository, configuring access controls, configuring repository upstreams, and some additional repository settings like retention rules and GeoIP rules. But really, the best evidence of how powerful a Cloudsmith repository is to use it. So we should probably publish some packages to this repository and then fetch them down in a software build and see how that all works. So let's just get started by publishing a package to this repository. Publishing packages on Cloudsmith is really simple. So we provide really detailed contextual instructions within the product. So I can see immediately here how to push a Debian package, for example. I can see the instructions for using the Cloudsmith CLI or the Cloudsmith API. And of course, for other package formats, Cloudsmith supports native package publishing. So for something like Docker, we can just do Docker login with our Cloudsmith credentials, and we can just publish a package with Docker push. So Cloudsmith supports native package publishing for all the package formats we support. But let's see how easy it is to publish just a Debian package to this repository. So you can see the Cloudsmith CLI command here. It's just Cloudsmith push deb with my workspace name, my repository name, and then for a Debian package, I specify the distribution and the version. I'm using any distro and any version for this package. The package is uploading to Cloudsmith and synchronizing. Synchronization is quite an important step. That's where Cloudsmith processes the package and extracts the package metadata and makes the package available for download. It's at that point that Cloudsmith has essentially processed the package and made it available in a Cloudsmith repository. So that's it completed and fully synchronized. We can now go back to Cloudsmith and have a look at our repository. So there is our Debian package. You'll see that the latest tag has been added automatically, but Cloudsmith also supports custom tags. So I can add any additional tags I want to packages and artifacts. And that's really useful because tags can be used to search for packages, to filter packages, and also to target things like webhooks and be a filter in other places. Artifact tagging is pretty central when it comes to package management in Cloudsmith. But we can look at the information we've got about this package now. So Cloudsmith shows us the checksums. We automatically generate a GPG signature for this package. All packages published to Cloudsmith repositories are signed. Cloudsmith automatically generates a GPG key, which is used to sign packages, but you can add your own GPG key if you wish to. And we can see additional information about the package, like who the uploader was, when it was uploaded, and things like the version number. Additionally, we'll allow you to see the files within the package. We'll also show you the dependencies of this package. So you can see a list of the dependencies for this Debian package here. And if you have any other versions of the package in Cloudsmith, we'll list those as well. So publishing packages and getting packages into a Cloudsmith repository is really easy. Typically, you'll use native tooling to do so. You'll do it from a CI pipeline, but it's so simple to get started.
Logs are really important to our customers, and we've invested heavily in our logs. We want to make sure that it's easy for our customers to debug, to know if an event has happened in their system. For example, a setting has been changed, so they can remain compliant and so they can have a secure software supply chain. Cloudsmith has a number of logs, including logs based on who's downloading your packages, who's push packages, and also our audit logs for all those events and settings changes. If I go into Cloudsmith now, let's look at our workspace level logs. So I'm clicking on my log section and we get our view here. We have the logs for the last 24 hours, but we can change that time frame to be even the last 265 days or custom time range. You can filter by package format, repository type, your repository, or package name. You can also filter by the actor value, so IP address, user type, is it a user API key or a service API key? And if an entitlement token has been used to fetch packages. If we click in and get more information about what kind of logs, what we get from the logs. Here for this Debian package, we have who's downloaded it, where it's being downloaded from, and what time it happened at, and where it's being downloaded to, EU West 2. We also have our audit logs in here. These will, any system setting that's been changed will be recorded here. A login event, for example, or if an entitlement token has been created, or even if a package has been quarantined. So if someone is logged in, if they've changed your setting, either at the organization level or the repository level, or you've added someone to your team, it's all going to be recorded in our audit logs. So this is at the workspace level. We also have logs at our repository level. So if I go to my platform demo repository, you can see our logs in the top right corner. You're again brought to the client logs, and you have the same filters as you did for the workspace level logs. You can change, you can filter by format, by repository type, by package name, and you can filter by the actor values. And again, you can change the time range. Again, our audit logs are here as well, and you can see any event that's happened relating to your repository. So now you know exactly what's going on in your organization, in your workspace, and in your repository. Our logs are exportable. You can export them to S3 bucket, for example, or Azure, where they could be consumed by your logging tooling, like your Seam or your Datadog, your Elastic, your Athena with AWS. We also have API keys, so you can consume our logs that way as well. So this means that you know exactly what's happening in your system, you know what's happening with your packages, all using our logs. Next up is Dan talking about how you can use Cloudsmith to consume your third-party open source packages.
Let's actually build a sample Docker image. Let's build an application into a Docker image. We will fetch all of the dependencies for that Docker image and for the build from Cloudsmith, and then we will publish the resulting build back to Cloudsmith. And we'll do it in GitHub Actions. We'll do it in a CI tool. So if I go back to my DMK Software Solutions workspace and into my repositories, you'll see that I have a repository called Web App Dev and a repository called Web App Prod. Again, that's leveraging the multi-format Cloudsmith repositories to essentially have environment-based repositories, one for development and one for production. Let's have a look at these repositories first. So you'll notice that these repositories have a lot of packages in them already. I'll group the packages together just so we get a better overview. So you'll see that I have Python packages, I have Docker images as well, base images, and I even have Docker images that I've built and published. If I look at the upstream configuration for this repository, I've got PyPy as a Python package source, I've got Maven Central, and I've got ChainGuard images for my Docker base images. So this repository is ready to go. It's been configured with Upstream sources. I have some packages in it. I'm ready to use it in a build. Now, I'm just going to change over to VS Code to have a look at a GitHub Actions workflow that I've written to build this image. So let's just go through this workflow very quickly. So you can see that I've set up some environment variables specifically to use Cloudsmith. So I've got my GitHub Actions, the name of my Cloudsmith service account. I've got my workspace name, DMK Software Solutions. And I've got my Cloudsmith repository name, Web App Dev. That's pretty straightforward. I've got a step where I authenticate to Cloudsmith using OpenID Connect, which is really great. I only need to provide my workspace and my service account. Don't need to store my service account API key in GitHub Actions. And then all I'm doing for this little application is just installing the Python requirements from the requirements file. That's it. From my Cloudsmith repository, obviously. I then Docker log into Cloudsmith to the same Cloudsmith repository, and I build and publish my Docker image back. So it's really quite a simple workflow. My requirements for this application are simple as well. So I just have 4 requirements here, 4 dependencies: PyTest, Flask, GUnicorn, and the Spotify web API client, the Python. So that's an overview of the project itself. What happens when we run this in GitHub Actions and fetch our dependencies from Cloudsmith and publish our built artifact back to Cloudsmith? Let's go and have a look at GitHub Actions itself. So I ran this build a few minutes ago, and I'll walk through the output. So you can see that we were able to authenticate successfully to Cloudsmith as our GitHub Actions service account. We were then able to install all of the dependencies from the requirements file from the DMK Software Solutions workspace from our Web App Dev repository. And even though I only declared 4 dependencies, of course, those dependencies have transitive dependencies. So there's actually quite a lot of packages that get fetched from my PyPy upstream and through Cloudsmith. You can see them all here. But that all worked successfully. I was then able to log into Cloudsmith with Docker. I was able to build and push my container image back to Cloudsmith. So it all worked successfully, and it worked very easily. Let's go back and look at the built application in Cloudsmith. So there's my Flask application in my Cloudsmith repository. I've got several versions of it that I've built. You will notice as well that this application, this image, has been marked as vulnerable. Our security scanning has detected a vulnerability. And we'll come back to that when I look at what happens when we use our production repository. But this Flask application has been tagged with 94. That's just the number of times I've run this GitHub Actions workflow. So I've given it the tag 94. We should be able to just fetch this image from Cloudsmith and run it really easily. So let's try that. So in my terminal, I'm just going to fetch Flask app with the tag 94. There it is pulling. So I've pulled that image from Cloudsmith, from my workspace, from my repository, and I should be able to just run that Docker image now as well. So I'll just give it the correct tag, and we'll just run it. So my Docker image is running now. We should actually be able to just hit localhost in a browser and see this. So there we go. So we published the Docker image to Cloudsmith. We fetched all the dependencies for that Docker image. We pulled it and we ran it. Very, very simple. But I want to go back for a moment just to this point about vulnerable packages and packages with a specific tag on them as well. So what happens if I was to try and build the same application using my production repository? And just to point out, the same thing that I'm about to demonstrate would also happen if we took this Flask app Docker image and promoted it to the production repository. I'll rebuild it here, but typically you would promote artifacts from dev to production. So I'll go back to Visual Studio Code, and the only update I will make here is to change the Cloudsmith repository that's being used. I'm not going to change the dependencies, the requirements. I'm not going to change anything else about the build. Just the Cloudsmith repository that's being used. So I'll save my change and I'll commit that. I'll just give it a message like changing to Cloudsmith prod repo. There we go. That's that committed, and I'll just push those changes back to GitHub. Now at this point, we can go back to GitHub Actions and watch this build. So there's our new GitHub Actions build, changing to Cloudsmith production repo. But this time the build was not successful. This time the build failed. We can see that it got to the same step where it went to install its dependencies from my Cloudsmith repository. This time, of course, it's using the web app prod repository. And when it went to install the Spotify Python package, it failed. We got an error 403, and that means forbidden. So right here it says forbidden. It means that package exists in Cloudsmith, but I'm not allowed to use it. So why did that happen? Why did it happen in the production repository? Why did it not happen in the development repository? Let's have a look at the differences. So just to point out, this package does exist in the dev repository. You can see Spotify 2.25.0 is here and is marked as vulnerable. But we were able to fetch that package. We were allowed to do that. So what is the difference about the production repository? Well, let's take a look. I can just search for the package to speed things up. There's our Spotify package. The exact same version, but you can see this time that the package has been quarantined in the production repository. So it's the same package, but this time it's been blocked and we're not allowed to use it. So why did that happen? Well, first of all, let's look at the vulnerability that's been detected in the package. So a vulnerability has been found. It's of a high severity, and Cloudsmith tells me the version that I need to go to remediate this problem. So instead of using version 2.25.0, I need to use version 2.25.1. But where did that element of control come in? What was it that forced the package to be quarantined? Where was that action taken within Cloudsmith? Well, that takes me back to something I mentioned at the very start. Package policies. Cloudsmith has enterprise policy management. What enterprise policy management allows me to do is to write policies as Rego. These policies are evaluated and executed by Open Policy Agent, and they allow me to take actions on packages in Cloudsmith repositories. This is especially useful for packages that are coming into a Cloudsmith repository from a public upstream source, like PyPy or Maven Central. So looking at this policy that I've defined here, you can see this policy targets the web app dev repository, and it is looking for an EPSS score. EPSS is the exploit prediction scoring system. It's like CVSS, only it's sort of more interested in how exploitable a vulnerability is. I have some other detail in my policy here around, is there a fixed version available? This policy will only trigger if there's a fixed version of a package available. And essentially, if it exceeds the maximum I've defined, then the action is just to tag the package. So in the development repository, I'm just adding a package tag. That's all I'm doing. But the difference in the production repository is quite subtle. It's the same policy, targeting the web app production, web app prod repository. But the additional action here is to quarantine the package. So we still add the tag for searching and filtering, but this quarantine action allows me to ensure that that package cannot be fetched and built into a production build of my application. Cloudsmith enterprise management policies are very powerful, and they essentially allow you to leverage any of the package metadata that Cloudsmith has. That can be things like the metadata that's inherent to the package, so things like the author or the maintainer or the URL. It can also be metadata like your repository names, your repository details, but essentially it can be any of the data that we hold and know about a package. That also includes security scan data that we have generated from our security scanners. It includes enriched data like that EPSS score. So there's a wealth of available data for you to use as inputs to a policy in Cloudsmith. It really is very powerful, and it really does allow you to implement really fine-grained controls over packages in Cloudsmith. Now, of course, you do want to be able to make exclusions to policies. And besides just adding the CVE to the policy itself as essentially an ignored CVE, if you have a package that has been quarantined by Cloudsmith, you can, of course, release that package from quarantine. Maybe there is no fix available, or maybe you have a 30-day remediation time for, medium to high CVEs. So somebody with the appropriate permissions can release this package from quarantine. And of course, the action of releasing that package from quarantine is recorded in the Cloudsmith audit logs for traceability. There has to be a break glass or an emergency escape as such. So just to sum up, what we did was we built a Docker image fetching all the dependencies from a Cloudsmith repository, from this repository. All of these dependencies originated on an upstream source. So in this case, the Python package index for our base images for the build, they were chain guard images from the chain guard registry. They were all fetched through Cloudsmith. They were cached and stored in our Cloudsmith repository, as you see. They were scanned for vulnerabilities. Our policies were then applied on top of that. Different policies in a development repository versus a production repository. And then we showed how the outcome varies in a production repository based on those policies. And like I mentioned earlier, whether I rebuilt the image against the production repository or I promoted artifacts from the development repository to the production repository, the outcome would be the same. The policy would kick in and it would quarantine those artifacts that violated our policies. So end to end, we've demonstrated how Cloudsmith can be used as a source for package dependencies that our applications need, and also as the destination for the built artifacts that our build processes create. In addition, we also demonstrated OIDC authentication in a GitHub Actions pipeline, so no need to store long-lived API keys in third-party services. And that really shows the flow of packages from public package sources into my Cloudsmith repository, through my policy engine, and back out again. Cloudsmith's enterprise policy management really helps you to control not only the flow of artifacts into, through, and out of your workflows and pipelines, but also to developers and end users and engineers. And it can really help you to achieve better levels in things like SALSA, or better compliance with best practices and frameworks like S2C2F. So I'd love to just hand back over to Ciara, who can go into a little bit more detail about how Cloudsmith can help you when you're trying to achieve that.
So compliance isn't just a checkbox anymore. It's a core part of how enterprise software is built at scale. Compliance ensures that software artifacts meet regulatory, legal, and policy requirements before they're promoted or released to production. Compliance is critical for managing risk in the software supply chain. It reduces vulnerabilities, license violations, and exposure to unverified third-party code. The damage caused by these can be significant financially and reputationally, and compliance gives a consistent and proven way to mitigate these risks. Artifact management systems like Cloudsmith that embed compliance into the pipeline can help teams catch issues early, apply consistent standards, and avoid costly rework or damage later on, where shifting it left. Common standards like PCI DSS and ISO 27001 establish security and compliance baselines for secure software supply chains. Frameworks like SASA, or Supply Chain Levels for Software Artifacts, and S2C2F, Secure Supply Chain Consumption Framework, are complementary frameworks that guide organizations in securing their build pipelines and responsibly consuming open source packages. As regulations like the EU's Cyber Resilience Act and industry-specific standards become more widespread, compliance is no longer optional, they're required. Teams must be able to show what their software contains, where it came from, and whether it meets defined security and licensing rules. Cloudsmith was designed with compliance in mind. Cloudsmith features like policy enforcement, our audit logs, and software bill of materials, or SBOMs. They help maintain compliance at scale. Signed packages help you prove authenticity and integrity. Cloudsmith supports both native and non-native signing, so you can verify what's trusted before it ever enters your pipeline. Trust is something that you build into the artifact itself. When you push an artifact to Cloudsmith, we apply a cryptographic signature, so you and anyone downstream can verify that it came from the right place and it hasn't been altered in transit. Let me go to the key management section in my repository. So if I go to Settings and Key Management, you can actually upload your own key pair so that every package is signed with your private key. Here. For all packages, we sign with either GPG key or the RSA key. But for certain package formats, we support native signing. For Swift, for NuGet, and for Docker, we support native signing using cosign. So here I have a Docker image, Dronebase, on my platform demo repository. If I go to my terminal, I'm going to pull that image. So here I'm verifying using cosign. I've downloaded my ECDSA key. And if I go cosign verify, you can see that it is verified that that Docker image was signed using the expected key. So I pulled my Docker image now, and I want to verify that it was signed using the expected private key. So I've done that, downloading the public key and using cosign verify. And you can see here the output describes that I've actually, that this image was signed using the expected private key. Signing and verifying your artifacts proves authenticity. Anyone can confirm this really came from our trusted Cloudsmith repository with the expected key. It ensures integrity. If someone has tampered with the package, then the signature will fail when you try to verify it. And so now you can trust your artifacts. And up next is Dan talking about how you can use Cloudsmith and our package delivery network to distribute your artifacts.
Cloudsmith is uniquely architected for global package distribution. Now, this is incredibly important for people like software distributors or anyone that is going to vendor or sell software commercially. Cloudsmith's package delivery network, with over 600 points of presence worldwide, ensures performant, low latency delivery of your packages to your users or customers, no matter where they are. And because this infrastructure is fully managed, you don't need to worry about replication or clustering nodes or setting any of this global infrastructure up. It's a core part of the Cloudsmith platform and how Cloudsmith delivers packages. But let's take a look at some of the unique features in Cloudsmith that really facilitate and enable that use case of software distribution. So let's just have a look at a Cloudsmith repository. So I have a examples repository here that's full of various package formats. I actually think there's one of every package format that Cloudsmith supports here. Again, this demonstrates the multi-format nature of Cloudsmith repositories. But what are the settings and the features that really enable secure, controlled distribution of artifacts? The primary feature is Cloudsmith's entitlement token system. You can see on the screen here that I have a bunch of entitlement tokens created in this repository, numbered customer 1 to 4. Of course, you can create and manage these entitlement tokens programmatically. So you can manage them at scale through our API or through our Terraform provider. I actually think one of the largest Cloudsmith customers manages over 1 million entitlement tokens across their Cloudsmith repositories. But what is an entitlement token? Well, you can think of an entitlement token essentially as an access key for a repository. It is a read-only access key. It's not an API key. It can't be used to log into Cloudsmith or to perform actions via the API. It's just for authenticating for package downloads. So if you imagine a scenario where you were selling a piece of software that you were distributing as a package, you would create a license key, an entitlement token for that software for your customer. They could then use that entitlement token to authenticate to Cloudsmith and download artifacts. But that sort of oversimplifies it a little bit. Let's look at a specific token in Cloudsmith and see what extra sort of features and functionality that they provide. So if I was to click to create a new token, I'll call this token customer 5. You'll notice that there's 2 sections here: visibility restrictions and usage restrictions. Now, visibility restrictions are very powerful. What they essentially allow you to do is scope this token so that it's only valid for specific packages within the repository. And that syntax is based on Cloudsmith search. So just like I'd said before that package tags are great for searching and filtering, this is where you could leverage a tag. You can restrict by things like the package name or the package version. And this is a fully Boolean search field, a restriction field. So I could say, name, foo, and version, greater than 2.2.0. And that would mean that this token is only valid for packages with a specific name and greater than a specific version. So you can actually even create a token here that's scoped right down to a single package or group of packages, any way you want. So visibility restrictions scope what a token is actually valid for, what that token can see within a Cloudsmith repository, and therefore what it can fetch, what it can download. Usage restrictions, on the other hand, control how much a token is allowed to be used. I think this is a really important bit when you think of distributing software commercially or privately. So as you can see, you can set a valid from and a valid to date. So you could create a token that was valid for 6 months or for 1 year. Particularly useful if you're selling a subscription of some kind. You can also set a maximum number of downloads, and you can set a reset interval for this. So you can say this token is valid for 10 downloads a week or 100 downloads a week. You can even configure a maximum number of IP addresses so that this token can be used from 5 unique devices, for example. That really gives you a lot of control over not just what the token can access with the visibility restrictions, but how frequently or how much usage can this token have? So if the package delivery network and the 600 points of presence are the infrastructure that power distribution through Cloudsmith, entitlement tokens are the feature that allow you to control distribution through Cloudsmith. So that gives you both the performance that you need to deliver those packages globally and the control that you need to effectively exercise who can do what with your packages or with your software. Entitlement tokens in general are a very, very powerful way to create scoped access to a Cloudsmith repository. Now, as well as that, we also support creating and enforcing end-user license agreements. So you can upload your EULA to Cloudsmith, and you can configure an entitlement token so that it isn't valid until the EULA has been accepted. In this way, you can make it so that your users or your customers must agree to your terms and conditions before their token is active for downloads. And then after that, you can have all of the restrictions, visibility, and usage that the token provides. Of course, as well, we also provide logging for each token. So you can see and look backwards at how much a token is used, where it was used from. That's really, really, really useful analytics for any software distributor. And Ciara will shortly talk in a bit more detail about logging within Cloudsmith and the different options we have for accessing those logs. So entitlement tokens really facilitate private distribution. But what happens if you want to distribute your packages publicly? Maybe you want to have anonymous access to packages. You want people to be able to consume, as much as they want of packages. You want to make your software widely available. That's a subtly different use case from private distribution beyond just the need for authentication. Cloudsmith has a public broadcast feature. What public broadcasts allow you to do in Cloudsmith is essentially create a branded, themed portal for a Cloudsmith repository. And it's really easy to get started with broadcasting. You can see that every repository has a start broadcasting button. I'll just click that, and it asks me to confirm that I really do want to broadcast this repository, and I'll do that. So this repository is now broadcasting, and I get the URL to access this repository. But what about configuring this? What about sort of making it my own? This is now a public repository. I want to present a good face to the world. How do I do that? Well, let's just switch over to the broadcasts mode within Cloudsmith. You can see that I'm just broadcasting one Cloudsmith repository at the moment, but I get a lot of really nice options here, particularly the ability to theme my broadcast. So you can see, and this is a preview of what my public broadcast page will look like. I can select my own color scheme. I can upload my own logo to brand the portal with my own sort of style. There we go. And I get to choose things like, do I want to show the total number of packages or downloads on the main page for my broadcast? I can also look at the broadcast page itself. So what it looks like in terms of what information I'm going to present as part of a broadcast. I may want to turn off the number of downloads or the total number of packages. I may want to change my accent colors to match a logo or similar. So this is a really easy way to present a branded, on-brand public face to the underlying Cloudsmith infrastructure, which is completely abstracted away here. Anybody can come along now and consume these packages from a Cloudsmith repository, and they get all of the same value that a Cloudsmith repository provides. So they get contextual setup instructions right in the product itself, right in the portal. They get all the information about the package, just like you would in an internal private repository. So broadcasts give you a lot of flexibility about how you present your software to the outside world. But at the same time, what you are presenting here are native package repositories. You're presenting the ability to do Docker pull and npm install and pip install natively for all of the package formats that we support. So while getting a very friendly presentation, you really still have all of the underlying power beneath that powers a Cloudsmith repository. So broadcasts are fantastic for public software distribution. And entitlement tokens are the feature that enables controlled private distribution. And both of these use cases leverage the underlying Cloudsmith infrastructure to serve packages globally through 600 points of presence, performant, low latency delivery worldwide without the need to manage or maintain any infrastructure at all. You just focus on packages going into Cloudsmith and packages coming out. So software distribution is a very important use case for Cloudsmith. But of course, software distribution itself is nothing without analytics and usage information about that distribution. Being able to see who has consumed what and when and how much is incredibly valuable information for anyone that distributes software. So one final thing that I'd like to look at, and maybe one of the most important things, is the Cloudsmith REST API. Now, up until now, everything I've shown you in the demo has been based in our web app, in our user interface, but our user interface is entirely API driven. So everything that you see here can be achieved with the Cloudsmith API. But more importantly, the Cloudsmith API can be used to build integrations and to further extend the Cloudsmith platform. We have good API documentation, including an interactive sandbox environment for the API. You can see here that I have an API endpoint to list all of the packages associated with a repository, for example. I can run that and see what the API response will look like. You can see all of the packages here. The documentation also provides examples of error responses and makes it really easy to get familiar and experiment with the Cloudsmith API. Now, I won't go through every single API endpoint because there are hundreds, but anything you can do in Cloudsmith, you can do with our API. One more example I would give is how you can use the Cloudsmith API to get information and logging out of Cloudsmith. So this endpoint that I'm showing here, that's the audit log endpoint for a specific namespace for a workspace. So all of the audit log entries exportable from our API into any analysis or reporting tool that you want to ingest those log entries into. And of course, we have a lot of other integrations. Some of these are built on our API, some of them are native integrations. We have a list in the documentation here covering all the common tools that you would use and be familiar with. CI/CD platforms, security tools, even things like notifications to Microsoft Teams and Slack. One of the most popular integrations in Cloudsmith is actually the Cloudsmith Terraform provider. So I used Terraform to provision all the resources for this demo environment, for example. So the Cloudsmith Terraform provider is very popular, very easy to use, gives you a lot of control over the resources in Cloudsmith. And of course, just like all infrastructure as code, it allows you to version those changes, track them and approve them. So as an example, I have some Terraform here. You can see where I've configured variables that I will read in for my repository names and my workspace name. I can then configure repositories, including things like which storage region I want them to be in. I can set different retention policies for each repository. I can set privileges and access controls, and even things like upstream repositories, upstream proxies and caching. To show you what that looks like when we run it, I already did to provision this environment, but I can show you what Terraform sees in terms of the Terraform state. And you can see there I have created a dev repository called web app dev, and I've created a production repository called web app prod. We can very quickly just take a look at Cloudsmith itself to see that those resources exist. They're the resources I used for the demo. So there's the web app dev repository. There's the access controls, exactly as I had specified in my Terraform code. That wraps up our tour of how you can manage your software artifacts using Cloudsmith. We hope that this has given you a taste of what you can achieve and why artifact management is better in the cloud. If you'd like a walkthrough that's more personalized to your specific organization or use case, request a demo. Our team loves to help. Thanks for watching.